Good morning, everybody. Welcome to another Random Code stream. I'm going to spend roughly an hour this morning doing some work, and then I've got to pack and get ready to head up to Canada. I'm going to Winnipeg for 2 days. I'm going to be speaking at Prairie DevCon. Actually, let me give a shout out to them, but before I do that, I remembered to put my camera at the lower right, like I should have. Let me get my music going here. But let me give a shout out to Prairie DevCon. So yeah, Winnipeg, they've done it in Regina and I think maybe one other city. But over the years, I think Darcy, because he lives in Darcy Lucier, he's the person who runs it. He lives in Winnipeg. So that's, I think, where he's really focused on now. And yeah, he has this conference once a year. They get about 200 people, and Darcy does a fantastic job at this conference. He really does. He treats the speakers well. He treats the attendees well. You know, they get a good show, and I've always been looking forward to going to this event. So yeah, I guess they're sold out. So if you're in the Winnipeg area and you wanted to go, unfortunately, I don't think they have any more tickets available. So. But keep it in mind for next year, because this is a really good event. All right. Before I get into more interceptor work, I did want to cover this real quick. This is a bug that came up because I was getting ready for Prairie DevCon and I was testing out something on my laptop, and I noticed this .NET tool that uses Roslyn to find the number of using statements you have in your code. Which, if that sounds kind of interesting, you can go to uget and then type in usings. And so basically you install this as a tool and then you run it against a directory. It looks through all your C# files and basically gives you a percentage of how many usings are you using in your files, because that might be those may be good candidates for a global using statement. So anyway, I found a bug and it was running against Roslyn, and I wanted to actually show the code because it's important. What I did wrong. So nope, it's not in here. It's in core detector. So yeah, right here. I used to say for each directive in the set of nodes of using directive syntax. And then I would say the name here with the exclamation point. But I didn't have a check on it to make sure it's not null. This is actually it's not a string. It's I think it's an identifier, or it's a name syntax. And so what happened is that I should have a test for this now. So what happened is I ran into a case where Roslyn had something like this, which isn't uncommon at all, and that doesn't have a name. And so that was coming back as null, and I was getting a null reference exception. So don't dismiss. Oh, I was hearing an alarm. I was hearing something beeping in my house, and because I have my headphones on and I have music playing, I was like, what is that? It didn't sound like an alarm per se, but yeah, that's what it was. So, oh, this is funny. I have one assert and I'm using an assert multiple. Probably don't need to do that. But anyway, that was the issue. So don't just exclamation point your way to happiness in code, because there's a reason these are there, and I got bit by it. I just said, of course it's going to be not null. Why would it ever be null? Well, there's one place it was null. So, yeah. We can always learn. All right, so getting back to this, I don't know how much progress I'm going to make on it this morning. I want to spend a little bit of time on it. Last stream, I got to the point where I could emit code where I was detecting that I was calling like define dynamic module, define type, constructor, get out IL generator, which is good. That's another step. The thing that I have to now figure out, I think the real underlying problem is I need to figure out when you call these methods, what do I actually do with them? Because as I mentioned, I think in the first stream, the wrapping layer that I originally created with this would have usings and have disposable objects. So I could tell when you were done with a certain section. I can't do that anymore with this. So, but that's important because I need to know, like when you've called define type and you call create type basically means everything within that type should now be defined. And if I call get IL generator, or if I call define constructor, or if I say define method, those types of things, they start to become really important in the ordering because I really need to know what is going into the text file at what point. And I've been debating basically taking two approaches to this. One of them is that when you call define type, that's a trigger to say, have I started making a symbol document? And if I haven't, then I start making one. I put in, like the fact that I need to do an assembly and all this stuff. If I do define constructor or define method, or there also will be things like define field, I think, and define property and stuff like that, but I'm going to keep it small for now. As a side note, I've also thought of a different idea to do with interceptors, and that may be the one I spend more time on. I've actually debated stopping the work on this because this does get to be a little bit tricky, and not a lot of people use System.Reflection.Emit anymore, but I kind of want to get through it too, because I want to at least show that I can do it. But then I've got an idea for an interceptor in another way. So that I think would be more readily approachable from a demonstration point perspective. So yeah, if I call all these things and I call things on the IL generator and stuff, when do I actually emit stuff to the symbol document? Because what happens if you define constructor and you get IL generator, but now you're also weaving in calls to another method, and that method calls a or you then start working on another type, and you haven't finished this one up yet, And if I just take it what you're doing as verbatim, things can get wildly out of order in the not just the symbol document, but the code document that I'm going to be making as well. So I've thought about potentially doing something where, wow, is my volume really loud? My speaking volume? It seems to be like pegging. But I didn't change anything on my, That's weird. Okay, I guess I'm going to have to listen to this later, but it seems like my audio is flying into the red just a little bit. Oh well, it's the fun of things getting reset. Let me actually just turn it down slightly. That's audio input capture. Let's just turn it down a little bit. Okay, now it's not as bad. All right. Well, I'll have to listen to this back a little bit after I'm done to see where I'm at. So part of me has thought maybe what I should do is somehow capture when these things happen. And once I get to the point where, because you have to call create type. If I go back to my program here, at some point you have to call create type, and that allows you to start using things within the type itself. What we would also need, hey Thokra, oh, you did Metal Gear Solid 2. I was watching Snamwiches play the release of Snake Eater, and I was quite happy that I decided to watch somebody play it than consider playing it, because it just did not seem like a game that I would be interested in playing. So, but anyway, so when you do all your create types, once you do the last one, that's where it would say, okay, now rip through all the things that you were waiting on to actually do, and then make those calls. That's a First Metal Gear Solid game. Okay. So like here, if you call emit, what I would actually do is capture that you tried to call emit, where you're passing in this enumeration and this value, and then just do like a closure around that call, and then just stuff it somewhere, And once I've counted down all the create types to where you're finished with all the types you ever said you were going to make on that, then I would, anything you ever did on that type, then I would finally actually do all that work on a document. So that would actually end up being quite a lot of work to do. So that's why I'm debating. Do I just want this as a simple example that I just trust that the order that you're going in is what you actually meant to do, if that makes sense? Or do I, because I said this before in a previous stream, do I just say this is for demo purposes, really, and I don't expect anybody to use this in any significant detail? I'm glad you like it, Thokra. I mean, it's, I think that's what's nice about having choice in games and different styles, because some games appeal to some people and other games to others, and if you get enjoyment out of it, that's what really matters. So, okay. So maybe instead of overthinking it, I just assume that you're going to go in the order. But the one thing that is still a little bit problematic is if you define a method or a constructor and you get an IL generator, you don't know when you're finished. You can't just say when you call return. That doesn't work, because you could call return, or if you're not, whatever you're doing in the method, you can't just rely upon that, because you could have different places where you return in a method. So I think we still need something to say if you call create type, or you call another defined method or another defined constructor. You have to look at, were you previously doing something on this type? And if you were, consider it now to be done. And so that would kind of force people to, if they did it this way, that they'd have to define the type, they'd have to define a constructor, do this, and then once they did this, that's basically saying the constructor is done. You do the method, you do this, and now if you had another defined method or defined property or whatever it is, define property. I think you can also say define constructor. You can do default constructor now. Oh, that's interesting. Define event. Oh, that's the constructor defined here is simply called the parameterless constructor of the parent. Oh, interesting. I didn't even know that existed. An event, field, method, property, type initializer, stuff like that. So there's more that you can do, but again, baby steps. So maybe I just say that if you call one of the defines, that means the previous defines generator is now complete, and so you can close it off, if that makes sense. And again, for my first POC on this, I'm purely trying to really replicate what I did here with my simple example. So now the way to do this is going to be interesting, because I need to actually, I'm just returning a string here right now to say I captured this call. What I need to do now is say something like, well, I need to return something that I can use when I say create output, because in this case now, it can vary. I may want to know that you called define dynamic module because that's the start of everything. And then if you call type, and then if you call constructor or method, in fact, I could throw that in here and say else if define method. You know, I could do that. And yeah, those are on the type builder and the constructor and the method builder. If they had a getIL generator call. So it's returning something that says, what is the thing that was called? And then what data comes out of this so that I can use it when I'm producing code. Which will be fun. And I do want this all in the same file. If you looked at the tests here, I do want to have something that will end up all being the same file, because everything, there's going to be something I have to keep around that I only want everything within this file to see. So I don't want to produce this with different, how do I want to say this? I don't want to produce this with different files. It's all got to be in one file, because some structure I have to keep in place to say, this is the thing you're going to work on, this is the previous thing you worked on, so that we can keep some state around. So it will definitely be a mutable object, whatever it is. I guess what I could do is create a structure that has something like how do I want to do this? Because we only want one instance of it around as well. So I could say something like, and I know this is just sketch code, file sealed, emit state, seal class, emit state. And so we could have something here like a public module state module get and set. And actually these all could be nullable. So, and actually we also are going to want this to have nullable enable on it as well. I think you have to say, wait. No, you don't need a semicolon at the end. Okay, that's fine. And so we say file sealed, and we could have a public module state. We could have a type state, type we could have a method state, because we don't really care if it's a constructor or a method. We just, they have to come through in their own order. And then an IL generator state. Now, it's also possible that as you're doing this, you could do this for more than one assembly. Unlikely, but possible. So we're going to want also a now one actually no, I just realized something. One thing that's interesting is, yeah, I'm viewing this as when you're doing a source generator or an interceptor, you want to work with immutable read-only stuff, but that's only for what you're pulling out of the create syntax provider. This stuff should all be stuff that identifies what you're trying to do. What we actually produce here, this can all be real things. Yeah, I just realized that. So this can be a module builder and probably global system reflection emit module builder. By the way, Throker, if you're still on, I'm kind of curious. Do you do any coding, or is this all like complete Greek? But what I'm trying to say here, and maybe you know Greek, so then. So a constructor is a constructor builder, but that should derive from constructor info. That derives from a method base, right? Maybe we keep a constructor builder around to say that you did a constructor, and we say here this is a method builder. Method. And then this is actually a emit dot, and those are IL generators, right? IL generator, yep. And so now we can actually name these as being current. So we can say what's the current module, what's the current type, the current constructor, current method, and the current IL generator. And then we could also put on this a public static. You could probably make it read-only emit state, current state. I think if we say this, sounds like a very simple singleton. Because again, we don't have to worry about anybody being able to see this or create it. We can use this in the code that we're going to generate, all the interceptors, to reach up into the current state. We'll always have a new one, and we can say, hey, when you've got a current module, or you do a module builder, we can capture that you did a current module. Nice. Yeah, I have the feeling I know where this stream is going to go, which it's going to look like I didn't do a lot, but this is actually really helpful for me to do because it's getting my head around how this needs to actually work, if that makes any sense. Okay, so we have this, and then if I did like the first interception, the first interception would be undefined dynamic. This is where now I got to go back onto my notes because I got to go look at go away. This is not plain text. This is Markdown. Come on. That's not helpful. That's not helpful either. Where are my notes on this? Maybe I gotta... Okay, hold on. Docs. There we go. We'll look at his. Uh-huh. So we can get interceptable location. We'll use that in our call to actually figure out what we want to. Yeah, that's the transform. That's a method he has. And then you register the source output, which calls this. This is that actually thing that does all the code generation. What we want to do in ours is what we also want to do in ours, hold on. I'm watching the time. I have plenty of time this morning, but I don't want to go spinning too far off into the weeds here. But my flight doesn't leave till like 3:15 Central, so I've got time galore. We want that at the top too. So I was trying to remember what that was. Okay. So what we want so you put the intercepts location, the version, and the data at the top. And then you say what you're trying to intercept. And if it's a static, yeah, so you're targeting an instance of an enum there. So what do I want to do here? I want to be able to generate something like file. So I think these all have to be file static class, module builder, interceptors, something like that. And then we do that for all the things that we actually end up needing. So you'd have an assembly builder, you'd have a constructor builder, potentially. I mean, you may not even create methods, although that's probably highly unlikely. Module, there would be a type builder here. And then an IL generator. And so those are the types that we would create, and we would put our calls that we want to intercept here. So for example, on an assembly builder, we want to see, do you call define dynamic module? And again, the shape of this method will vary depending upon what version, the runtime you're targeting, whether it's .NET Framework or .NET, which is fine. But we would end up having something like, go back down to what they're doing here. You'd have a global system runtime compiler services dot intercepts location, and in all likelihood to be 1, and then blah. That's the stuff that would actually come through with the interceptable location. And then we would have a public static. Let's look at the .NET 4.8 version because it's simpler, sort of. We're going to have a dynamic we're going to have a global system reflection emit module builder, except that define dynamic module, and then that one will have a this system reflection emit assembly builder assembly builder. And what's that called? Come on. Let's move this over here. So you have string name, string file name. Let's actually just go to this because we can probably then copy it in. So we would want, this is the self. I'll call that the self. And then we have that. So assuming that we've caught the call, and we're going to say we're going to accept it when it's at this location. When you call define dynamic module, these things, we're eventually going to say return self.define dynamic module, passing in name, file name, and emit symbol info. Okay. But what we want to do here is say if emit we're going to want to have our own namespace here. We're going to want namespace EmitDebugging. And then we want all this thrown in there. Just to be correct in that we have our stuff scoped. So we define a class in there. We could say, just so that we're doing everything correctly, that would be this. So now we could say if global doing state EmitDebugging current state dot, because that will always be non-null. If the current state, the current module is not null, to do finalize. If that makes sense in my head, but What I mean by that is you're gone through and you've done all this stuff. And so there may be methods that we put on the emit state with the symbol document and also this code document that I'm going to be creating that will that we can have different finalize methods. Like we can say here, finalize module. Finalize module would say finalize a generator if it's there, finalize a method if it's there, finalize a constructor, finalize the current type that's there. So we could say on the emit state, we could have a public void finalize module. And then we could have those for, like we know this would want to say this dot finalize type. And that would be this method. And finalize type would do something like this dot finalize constructor this dot finalize method, and it will also do things like finalize a property if we've defined it or something like that. By the way, if you haven't subscribed to the channel just yet, please do so. I would greatly appreciate it as I'm trying to get to 5,000 subscribers, so any new subscription helps. So thank you in advance for that. If you've already subscribed, I appreciate you for doing this. And again, you may be wondering, what in the world is this guy doing? Just, it's complicated. This has actually turned out to be kind of like a sketch episode. Well, I don't mean like sketch like it's bad. It's just I'm sketching out ideas here. So finalize constructor, we would say this dot finalize IL generator. And then public void finalize method would also do that. And then public void finalize IL generator would do stuff. Now these are all going to do things with the symbol documents and the code documents, but right now we just want to kind of sketch out what the ideas are here. So we would say, actually we wouldn't have to do this. We would just say, go to the current state and finalize the module. Then we're going to say var module is equal to this. We're eventually going to return it. But then we're also going to go back to the global and we could also have initialize method for all these too. We could say something like initialize the module, because then that would go through and make sure that what could that do? Initialize module could do something like do all the cleanup. And so we don't do a finalize, we just say yeah, we would call these initialize module. Except the thing is here I want to pass in a I would want to pass in a module which might say something like, we'll finalize the type. You want to look at the current type and then do whatever work you would do on these things. But it would be nice too to have a method that says, here's the, somebody's creating a module, so go off and do something with this. Handle a module. And handle a module would have to say, do we currently have a module in place? Do we have a type in place? I'm overthinking this, but I do want this to be somewhat somewhat usable from a demo perspective. Which, no, I'm not going to even try to get this finished for PDC. I'm definitely not going to have a demo for. I was thinking about it, but I'm like, no, there's no chance, not at this point. And the talk that I'm doing on Roslyn, I don't even have time to get into something like interceptors. I only have 60 minutes, so I've really got to focus on what I'm talking about. If we do a finalize, that does a sweep of everything. And then if we do an initialize, then because again, we're having complete control over all this stuff. We know when things are being set. So we can make these private. They're only internal, and that it changes based on the states of these things. Okay. I'm fine with that. Hello. So if I say initialize module, passing in the module, then I would actually have something like this. And this would definitely not be null. And so then we would say here, this dot current module equals that. And by the state of how we're doing things, I think we would always assume that everything else from the finalized perspective is going to null out their stuff after they're done emitting all the things they do. Like finalizing a module here, say finalize the top, this dot current module would end up becoming null. And then with the type, we would say here, this dot current type becomes null. This one we would say current constructor becomes null. This one, current method, would become null. And this one we would say this dot IL generator would become null after we do whatever we need to do. Okay, this is starting to become more of a plan again. So if we say initialize module, all we're doing is capturing that we have a current module in place. Okay. If we would do a module, yes, we would also want to have something in here. Well, no, I think these just control the state. And so when we say initialize module, we want to say to do, well, no, let's just do it right now. Because it goes in lockstep with yeah, and again, the defined document here, we have to emit it, and we have to emit it based on the way of what you're calling here, if that makes sense. But this is something that the user would not do. So we could have in here, we could have a, what does that end up being? A document, I symbol document writer. I symbol document writer, because of course. I symbol document writer. Current document writer. Get private set. Easy. And so in here, this would generate something like this, except to be this.current document writer is equal to our modules defined dynamic writer. And of course, we don't have an assembly name, but we can get it. Module.assembly.assembly get name. So here we would say that. Sim document type is system diagnostics symbol store. System diagnostics symbol store. Global. And I'm assuming the language type is as well, and so is the vendor. Yep. All right. And then I think having things just on their own lines will make stuff easier, also for readability. So that works. And so again, when we call dynamic module, we intercept it. We first clear out our state at that level. The module say define dynamic module. And then we're going to initialize our module, which what that will do is set the current module to that. It will also set the current document writer to that. So actually here we would want to say, because we are responsible for doing that as well. So now we have a symbol document writer. Okay. What about a module builder interceptor? Well, that can do things like, and actually here too, when we say initialize, we're going to have a document writer, but we also want to have a current code document. And actually maybe calling this symbol document writer makes things a little bit more, because we want a code document as well. This will be something that will be in EmitDebugging. We already have it, but we're going to call it the code document. Current code document. And so this needs to be set as well. This current. Doc global EmitDebugging code document. I forget, but it will be stuff. There will be stuff there. Current code document will be equal to no. Cool. All right. And so now if we come back down here, the next thing that you would do is define a type. And define type would do something like this. And so here we want define type. And this gives you back a type builder. And this is done on a module builder. Okay. And the things that we are passing in here are these things. And again, I think for consistency, just when we're emitting stuff, emitting the code for the interceptor, I think it makes sense to, this is system reflection. So that would be And then this is, I think, just system type, not reflection. So now here we say finalize the type. Because you're defining a type. So we want to finalize if we're assuming you've already done the same module, which may be incorrect and technically is. But again, we're assuming that you're defining these things in a certain order. So we're hoping that the module you're giving here is the module that we have. Again, I can think of ways to be more defensive around this later. So we finalize the type, we initialize the type, because we're actually going to call here, we're going to say module, we're going to say type here, we're going to call define type, we're going to pass in the name, the attributes, and the parent. And then we're going to initialize the type, giving the type, and then we're going to return it back. Okay, so then up here, when we have an initialized type, and we have type here, we could say type builder, but that's fine. Type builder. Now we're going to say current type is equal to type. We don't need to do that. We've already done that. But now we need to do something here to write out code. We don't need to put in a symbol debugging point here. That's only when we do IL generation. But we do need to put in the line indented right to say that this is some kind of type definition at this point. So we're going to capture that as well. Again, all this is just sketching out what I did in a test and what I think the generated code should look like. This would vary wildly based on what you actually end up doing in your code. But yeah, that's fine, if that makes sense. So, because I think what we would want to capture out of, if I go back to my builder here, not my builder, my generator, if we capture a specific method, what we would want to know is just the method, its parameter types, its parameter names, and that's it. And so we can have a structure. If I go to my analysis here, we could put in some like an invocation model. And so what this invocation model would have is potentially the name of the invocation, we would want parameter info model, sealed record parameter info model, where a parameter, we could just capture the type as a fully qualified string. We don't need really anything else. And then the string is the name. Oh, fine. Yeah, I forgot we need the polys. We need the polys. Oh, that's in tests. I was like, I should have them here. Polyfills. Okay, so let's come back here. Let's go into analysis. Let's make a polyfills. Wait, what did I call it? Polyfills. I'll get to your question in a moment. No. We want that. And then grab this, put that there. Now you should shut up. Yes, you do. Yippee. Okay. Can you like summarize what you're doing here? God, I wish I could, Lemon. Oh. So this is a library that I wrote years ago that basically was binary compatible, one-to-one with System.Reflection.Emit. And what it would do is basically make a debug file with symbols underneath the scene for you, so you could actually go into the debugger with the code that you emitted, the IL code. The problem with that, though, is that you weren't using the System.Reflection.Emit types proper. You had to use these wrapping types. And so I had actually archived the repository because it was fun to do years and years ago, but for some version of fun, but it was just not useful anymore. And I've been thinking about, I need an example for interceptors in .NET. So I thought maybe I can intercept all the calls of System.Reflection.Emit and handle it that way. So that's kind of like what I'm doing here is I'm writing an interceptor to intercept System.Reflection.Emit calls so it can make a symbol document for you underneath the scenes and you don't even notice. I have another idea for interceptor, but I'll work on that at some future point. I do want to finish this. It's going to take some time to finish it, but I do want to finish it. So, and actually we can get rid of these calls here now because we're not going to have them. All right, so I said an invocation model. We do want from rocks because everybody copies this. Everybody copies this. Where's the... Did I put it in here? Equatable array. Yep. Everyone wants an equatable array. And so we're going to call this EmitDebugging. There. Oh, I see. I get it. Okay. If you do, awesome. So, and by the way, thanks for subscribing. I appreciate it. Not that what I'm saying is like impossible for anybody to ever understand, but it is definitely off the beaten path. That is for sure. Equatable array of parameter info model parameters. And then we probably also need string. That's the name of the invocation. That's the number of parameters we're having passed in. And of course, the parameters can get very complicated. They can have outs and all that stuff, but we'll get back to that later. I know all that from rocks. And then we could have string return type, which could be a void or which could be an actual type. And there could be attributes that we have to add and all this other stuff, but we'll come back to that later. Again, this is really just a proof of concept type of thing. So, all right. So we said if you do a module, we do all this. If you do a type, we do all this. If you're going to make a type, you could be do things like defining a constructor and defining a method and field and event and all that other stuff. But we'll come back to that later. Okay, close all that out. Parameter has a type and a name. Sure, that works. Okay, so we're assuming we're going to intercept the call like, oh, I don't know, define constructor. So if we look at what we did here, not here. Wait, where am I want this program next to it. That one's the easier one because that's .NET Framework. So I could say I want to do a define constructor call. And of course there's overloads, but we'll be dynamic with that. So I could say define constructor. And this would give back a constructor builder. This would be a type builder. And then in this case, what we want to call is something like this. So that and method attributes, That's in system reflection. So we say global system reflection dot method attributes. This is calling conventions. It's also system reflection. And then this would be just system, because that's where type is. Okay, so we say finalize type based on what we passed in here. So finalize. Wait a minute, no, we don't pass those in. Not on the finalizers. Not the .NET finalizers, but the... So here we would say attributes, calling convention, and parameter types. It's actually, when I think about this, the interception part can work to be very dynamic to say, I want to call define constructor, but I don't care what overload you're calling. All I care is that you're doing this, and then here are all the parameters. So just emit an interceptor with these parameters and this return type. And then within it, we can say what you want to call this too. So we'll just pass in those things as well. I understand what you're doing. What do I need to learn? Oh. Preem. That's a tough question because there's a lot. This is... What I'm building here is something called an interceptor, and an interceptor allows you to intercept invocations in .NET. This is not like a interceptor where you can intercept any invocation as your program is running. It's only invocations that exist within a particular program that the compiler sees, like you're calling a method. But it's a feature that uses Roslyn. So you have to understand Roslyn, you have to understand interceptors, and then the specific thing I'm doing here is intercepting what's called System.Reflection.Emit. This is a library in .NET that allows you to do IL generation or assembly generation using the intermediate language. So there's a lot of complicated stuff here that's going on. It's not typical. It's not what people typically do in .NET, but it's also fun stuff and it's powerful stuff. So that's why I'm looking at it. So here, if I say finalize, now we'd say finalize constructor, and we would say initialize construct. No, initialize. And so what we want to do here is call, this is now a constructor, which we'd pass into here, and we do that. I'm seeing the vision in my head. You may not see the vision, and that would be totally fine, because if you could, that means you could read my mind. That would be a little system reflection.emit constructor builder constructor. So I would say here this dot current constructor is equal to the constructor. And then again, we're going to do something where we're going to write to our code document. Initialize. Thank you, spelling check, that they added in Visual Studio recently. I appreciate you. We can also do the same thing here for defining a method. So go back to our program here. Let's see if I can get to a certain point. So I say this, I say finalize method. I'm going to say initialize method. In this case, I am calling this overload, which has these things on it. CS undergrad, currently studying Java Spring Boot tech stack. Cool. I know nothing about that other than those are words. I mean, I know what Java is. I know what Spring is, to at least to a very high level, but those are things I don't spend my time on. Most of my time in my career has been in .NET, for good, bad, or indifferent. I think it's been good, actually. All right, so we have our interceptor here, We're going to finalize the method. We're going to define the method. We're going to pass in attributes, return type, and parameter types. Because constructors don't have return types, so that's why it's a little different in that case. And then we initialize the method, and we're going to return, this is a method. So we're going to just say we're going to return the method, and when we initialize the method, we'll come up here. Very similar to initialize constructor. We're going to say initialize method. Method, not method. Method builder, passing in a method. So we would say current method. And again, a to-do, we will come back to that and add stuff about a method. The last one that would be nice to just show here. Oh, I'm putting, oh, these are the constructor. Okay, yeah. Constructor, and then we have method builder interceptors. Okay. So constructor and method builder interceptors would have the same thing, which is if I say get IL generator. So we want to say on a constructor builder, we want to say get IL generator. And the this, in this case, would be a constructor builder. Constructor. Heard that .NET is difficult to understand for beginners. I think comparing .NET and Java is almost the same, and I would argue to say .NET's actually somewhat easier. I do have a bias, though. I mean, I've been doing it for many, many years, so it's something that I'm used to. But is it more or less difficult? I don't know. I've heard Python's really easy, Python's a very simple language for people to pick up and be very productive in. Arguably true, but I also find languages like Python that don't have type safety to be potentially big killers in productivity, because you can start having to, I mean, there's a reason why TypeScript was made. Well, a lot of reasons. One of them was just adding a sense of type safety around JavaScript. And I like typed languages. I like strongly typed languages. Now, is .NET harder or simpler? Again, it depends on your view. I know they've done things over the years now with C# to make it so there's less noise. Like if you want to create like a program file, typically you'd have to make it so it had a static class called program and a static method called main. You don't have to do that anymore. You can just start typing. You don't need the static void main. You don't need the program stuff. So a little less verbiage. They're adding in .NET 10 the ability to have like single file projects. So not projects, but you can have one file, and you can have NuGet package references in there, and you can just write your code and run it, and it just runs. So that makes that simpler too. So I don't think I'd agree with that, Priyam. I know that's what you're saying you heard, but I would personally say complexity is somewhat objective, but it's also subjective too. What's complex to you? So I don't know. That's just my small take on it. Okay, so get out a generator. We'll do that. We'll say something like this. And just as a side note, you may be looking at this code. This is code I'm going to be generating. I'm just sketching some stuff out. Typically, I wouldn't write code that has this huge type name here either. When you're emitting code using a source generator, you do want to do this because it makes things easier to manage when you're emitting code. But again, this is something that you don't do a lot of at all. In fact, I think you could be a happy .NET developer for decades and never, ever run into something like this. Okay, so we would want to say here var IL generator define or get IL generator, and then here we can do this initialize IL generator. and then return that. And then the same thing we could do in a method builder because it also has the ability to do that. Arguably, I could put this on a base type and say, but I think, if I remember right, a getIsleGenerator is defined on, yeah, it's defined on the class. So, okay, fine. We would want to do this. IsleGenerator, initialize IsleGenerator. Thanks for the sub. I appreciate it. All right, so method builder, we have that. The last thing we would then start getting into is IsleGenerators. So for example, if you called emit. So I could say here, this doesn't return anything. This is a void. We could say emit. Except it also takes System.Reflection.Emit opcode. System.Reflection.Emit opcode. Opcode. And of course, there's many overloads of this, but that's okay. You suggest to me which tech stack to learn for Java. That's so hard. But I mean, the easiest ones to answer are the ones that are the most popular. If you look at jobs that are out there, I think .NET is a safe bet. I think Python is too. JavaScript is. Probably Java as well. But I don't think it's just languages. I think it's also understanding concepts, because that's a real big I know when you're trying to get a job, you have to show that, well, I have X amount of years on something. But if there's one piece of advice I can give to people is, yeah, learning those things, you do have to do that, and tools are making that easier and easier over time. But it's also just understanding good engineering concepts, good software development practices and stuff like that. That also helps as well. All right, so finalize the generator, get the IsleGenerator, but that's not what we're doing here now. We're not finalizing anymore. We're assuming that if you got to this point that you're doing it on the generator itself. Which kind of begs the question, no, we do want to capture the generator because we may need to do some stuff on it later. So we're just going to, okay, fine. Made no sense to anybody but my own head. We don't return anything. We're not doing anything. What we're saying here this time is we're saying you're going to emit the opcodes. But what we also want to do here is we say constructor method, and then we also have a initialize IsleGenerator. IsleGenerator. Except I don't think in this case we need to write anything at the document. That's fine. Okay. But if we get down to one of these methods, what we want to do is what you're seeing here. We want to do something like we are going to want to do this, but we also want to do that in concert with this, the current state, current code document, right? Because here we're going to write out, if you did an opcode emission, we're going to write out that you did that, and then we're also going to mark the sequence point. which of course the numbers here are off. They're not what we're looking for here, but we want to do something here to say, write that out and mark it the sequence point. But that's not the, that's in the generator. Passing in the document. Yes. So this now would be current state, current symbol document. Those things. And what did I call a symbol document, or did I say? I'm probably mixing up my names here. Let's call it just a current symbol document. And so then down here, when we're actually going to intercept, yes, we'll do all that. Because again, the thing I'm not trying to do is be cute with, could somebody be partially defining a constructor and then throwing in a method definition in there at the same time and all that stuff. I'm not trying to do that. I'm assuming you're going to go in the order that you should, because this is just illustrating a point. If I ever need to get to that point, I'm going to have to make this more complicated to deal with, you know, potentially these having lists of things and these knowing when it can actually put things in the symbol writer and the document, code document. That can get a lot more complicated. I'm really trying to avoid that. But even though none of this will work, and this is a test, and I have not actually done anything with the code interception and generation per se, this has actually been really helpful, because this is getting into my head. Okay, what are we trying to actually get to at a certain point? And so now that I've got this kind of sketched out, I kind of know, okay, when I intercept a method like module, I'm going to have to capture all of the parameters and their type names, and then put those parameters into a call like this. And, you know, same thing with a module. So that way it's flexible with, are you targeting .NET Framework or .NET or whatever. Like these calls, if you call emit, well, there's many overloads to emit. So we'll just get all those parameters, their types and their names. We'll pass that into emit here. We'll pass, you know, code documents also going to have those overloads, but that's just an API I can handle. And then we call mark sequence point to say, based on how much we wrote, what do we do? So still a lot of work to do. Hey, Bug. By the way, Bug, I think you'd be happy to know I almost debated doing a little bit of Silksong this morning, but I'm like, no, I'm going to go do some coding. I'll do the Silksonging when I get back on Wednesday. I'll get back Tuesday, but that's the finale for Alien Earth, so I got to watch that first. And then Wednesday, I'll probably do a couple streams during the day of Silksong, so we'll get there. All right. So this is actually, I think, good and valuable, but I am going to stop here because I got to get some stuff done before I head off to the airport. So I want to thank everybody who joined. Again, I realize this stuff is very abstract, off the beaten path, not stuff you're going to run into as a C# or .NET developer, but hopefully in a couple more streams with this, I can start getting to a point where I can actually demo it and show you this is actually what it's doing. And I think that's when things will click, but we got to spend more time to get there. So again, thanks everybody for joining. If you haven't subscribed to the channel just yet, please do so. I would greatly appreciate it. Trying to get to 5,000 subscribers as my next goal, so any new subscription helps. So thank you in advance for doing that. If you've already subscribed, as I always say, I appreciate you for doing that. Next stream that I do will be on Wednesday. Those will be definitely gaming streams. And Thursday and Friday I have off this week, so I'll be getting some more streaming in. I will probably try to get another coding stream in as well sometime with that, but nothing for the next 2 days because I'm out of town. So with that, I'm going to end the stream. Thank you all for watching. Take care, and I hope to see you in the future.